Welcome to the Logic Series Video Tutorial Volume Imaging Guide. This video will help provide you with an introduction on volume imaging using 2D probes. From the Advanced 3D tab on the touchscreen, you have a couple of buttons on the lower right-hand side which offer some helpful data manipulation functions. You'll notice the Reslice button defaults to cube, which is what we've been working with. The Reslice button also offers the ability to select virtual rescan. This allows you the ability to easily translate through the data set using the trackball. To do this, set the hand inside the cube with the right trackball key and translate back and forth using the trackball. Set the hand outside of the box with the right trackball key to manipulate the data set in any angle to visualize the anatomy of interest. Rolling the trackball up and down rotates the data set around the x-axis, and rolling the trackball left to right rotates the data set around the y-axis. Set the hand outside the box to rotate the cube around the z-axis, or cartwheel, with the left trackball key. Set the hand inside the box to move the box position with the left trackball key. This is an easy way to translate obliquely through the anatomy of interest while in virtual rescan. Above the Reslice button is a button labeled Group Planes. Group Planes Main and Group Planes Parallel provide advanced ways to manipulate and view the volume data set. Let's take a look at Group Planes Main. This advanced viewing screen allows you to see the full cube or 3D dataset segmented by 3 orthogonal planes and then display those planes independently of each other. A green axis dot is the point where all 3 of these planes intersect. You will find this advanced view useful for displaying pathology in all 3 orthogonal planes and transitioning from 2D imaging to 3D imaging. Move the axis dot from where it is to where you would like it to be by rolling the trackball. This will change the position of the hand. Position the tip of the finger where you would like the axis dot to be. Then double-click with the right trackball key. The first click moves the axis dot and the second click releases the hand. If you select the right trackball key once, the hand will grab the image plane, so when you roll the trackball, the plane will be translating or parallel shifting through the dataset. You can see the image plane moving using your orientation display in the upper left-hand section of the screen. While in Group Planes Main, you can also use the Z technique to visualize the coronal plane of any organ. Use the red hand and the right trackball key to parallel shift. Roll your trackball through the dataset to find the anatomy of interest. Then select the right trackball key again to release the hand. Place the tip of the finger in the anatomy of interest, for example, endometrial stripe or gallbladder. Then double-click on the right trackball key. This moves the axis dot to the anatomy of interest. Next, move the white hand to the left side of the blue box and left-click. When you roll the trackball, it will Z-rotate the anatomy of interest. Manipulate the plane so the organ is horizontal to the 2 red reference marks. Then, move the white hand to the left side of the green box and left-click. Roll the trackball to Z-rotate the anatomy horizontal to the 2 red reference marks. When you align the blue plane and the green plane, the red plane goes into a nice coronal view of the anatomy. Last, move the white hand to the left side of the red box and left-click. Roll the trackball to Z-rotate the anatomy. For the endometrium, you may want to see the fundus upright. In the lower right corner of the touch panel, select the Group Planes drop-down and select Parallel. Look to the touch panel and increase the tile number from 4 to 6. Then, move the hand into the first cube and translate, pulling the first frame forward. Move the hand into the last cube and translate, pushing the frame backwards. The system will slice the dataset into 6 equidistant slices after you determine the first and last frames. This allows you to show multiple parallel slices through the dataset. As you've seen, your Logic ultrasound system has the ability to acquire volume cine clips. From these clips, you can extract 2D still frame images, annotate or measure as needed, or even generate a volume dataset. With a little practice, you'll get comfortable generating cine clips and be able to tap into the benefits of volume imaging. Remember to use the VIP tabs to label your cine clips. Mark Cine using the lower trackball key, then sweep the transducer through the anatomy of interest and store your clip. Be sure to include 2 orthogonal sweeps for each structure and image the color and Doppler images as needed. If you want to generate a volume of information, optimize for frame rate when acquiring your cine clip. Pull your 2D images from the cine clip by reviewing the clip. You can do this frame by frame using the toggles associated with your Cine tab, or simply roll the trackball until you have the desired 2D image. Capture the 2D still frame. Measure the 2D image as needed. Once you have retrieved your desired information from the Cine clip, you can end your study. Or, if you need further evaluation, you can load this Cine clip into a volume dataset and virtually rescan the data without the patient present. This will help improve diagnostic confidence and productivity while reducing the need for rescans. Thank you for viewing our Logic Series video tutorials. Please come back soon for more tips on using your Logic system.